let's discuss the definition of logarithm of real numbers. As we know about the index notation is a methodology to write very large or very small numbers in a brief, short way. According to this definition, we become familiar that logarithm is also a useful tool for accurate and rapid computation of large or very small numbers in a very easy and comprehensive manner. So let's discuss the definition of logarithm of real number. If a raised to power x is equal to y, then x is called the logarithm of y to the base a and is written as logarithm y to the base a is equal to x, where a should be greater than 0 and a should not be equal to 1, as well as y should be greater than 0. In this definition, we observe the two statements. Number one is a raised to power x is equal to y, that is exponential form. And the number two is logarithm y to the base a is equal to x, and that is logarithmic form or simply log form. So we have to keep it in mind, these two forms. The one form can be converted to the other and vice versa. So it means, first of all, we have to learn the concept of the conversion. As we observe in these two forms, the base remains base, whereas these two values x and y, they exchange their positions. So if we become familiar of this phenomena, that the base will remain base in both the forms and x and y will exchange their position. So let's clarify this by an example. If we have 3 raised to power 4 is equal to 81, so it can be written in logarithmic form as log base will remain base, base will remain base, 81 that will change its position, that will be written as a log 81 to the base 3, and exponent will become the equivalent value is equal to 4. Let's have another example. If we have a value like log 32 to the base 2 is equal to 5, so we can convert into index notation as 2 base remains base and that value is exchanges positions, so it will become exponent 2 raised to power 5 and 32 will become equal value. And if we check 2 5 times, the 2 5 times is equal to 32. It means the logarithm is also a source of computation of very large or very small numbers, which are actually written in index notation. By these examples, we come to know that these two forms can be converted to each other. Index notation, index form can be converted into logarithmic form, and logarithmic form can be converted into exponential form, index notation. So it means these two relations are equivalent relations. Equivalent relations.